All right, hey guys. When we last left off yesterday, we had looked at multiplying and dividing rational expressions. So example 1 in A and B part had us multiplying them, simplifying and stating the restrictions. Example 2, it had us, B part had us dividing, and example 2 had us multiplying where there were slightly more complex terms. I haven't received too many homework requests yet, so as of right now I haven't included any. Maybe if I get more, I'll sort of make an addition to this video and put it at the beginning. But first things first, we're going to carry on with the lesson. So today we're going to simplify and state restrictions again, just like we did yesterday. But today, if you look, the operation involved is addition. Now, rational expressions, you'll remember, we said are any expressions that contain a fraction. So here we are with example 3, question A, and we have a fraction plus a fraction. Now the first thing you may remember is we said that we like to check for restrictions right at the beginning. And here we have 1 over 7b and 1 over 5b. And so the question is over here already, what do we know? What can x not equal? Well, we can never divide by 0. And since we can never divide by 0, we need to make sure neither bottom equals 0. And here if I make b equal to 0, 7 times 0 is 0. So that's a restriction for this. And 5 times 0 is 0. So that's also a restriction for this. So in this case, x cannot equal 0. I want to quickly show you what these two functions look like. So if we have f at b equals, what was it? 1 over 7b. We know when I punch this in that b shouldn't be possible at 0. And if you look, here we get an asymptote, which we talked about earlier, where x will get really close to 0 and begin to go down really fast towards negative infinity. And here if we approach from the right side, again we'll get really close to 0, but we will never get there. And if you look, if we try to evaluate f at 0, the answer is infinity, which again is undefined. It's not something we can put on here. And 1 over 5b will give us the exact same result. If we look, it changes shape ever so slightly, but in general, it's pretty much the same function. So there's 1 over 7b, there's 1 over 5b. Quite similar. Now, to add fractions, we must find a common denominator. We need to find a common denominator. So we will make a note of that here quickly. We're going to find a common denominator. So with that in mind, to find a common denominator here, the first example is pretty simple. You know that if we were adding the fractions 1 over 7 and 1 over 5, we'd have to look for something that both of these can multiply to. When in doubt, the easiest thing is the numbers themselves, multiplied together. So in this case, 35 is definitely a common denominator. So our common denominator is going to be 35, and obviously we need to make sure we include the b. So the denominator for each will be 35b. So the first fraction here I'm going to put over 35b, and the second fraction here I'm also going to put over 35b. And the question just becomes, what do we have to multiply this by? Well, I had to multiply this one top and bottom. To get a denominator of 35b, I have to multiply the bottom by 5. And so I must multiply the top by 5. And what we end up with is 5 over 35b. Now here, to get 35b as a common denominator, I have to multiply the bottom, which is currently 5b, times 7. And if I multiply the bottom by that, then I also have to multiply the top by 7. And so what we end up with is 5 over 35b plus 7 over 35b. And once the denominators are common, I can put them together and I can do the addition. 5 plus 7 is 12. And there we are. Now, If possible, I would reduce this, but 12 and 35 don't reduce. And so that's it. We're done. That's the simplified answer. 1 over 7b plus 1 over 5b equals 12 over 35b. And the restriction is that b can't equal 0. It occurs to me that up here I said that x can't equal 0, but obviously I meant b. All right, so that's an easy example where all we had to modify was the number. Sometimes, however, we get much uglier examples. And the next few start to get that way. Here, in b, if we look, we again have to find a common denominator. But this time, on this side we have 2xy squared, and over here we just have 2y. So the question is, what is already common about them? Well, they both already have a 2 and a y, but this one has an x, and then it's multiplied by another y, so it's y squared. And so we can actually use this as the common denominator. All right, we can say that the common denominator will be 2xy squared. Now the nice thing with that is, do we have to multiply this by anything? No. So we can just rewrite this one just as it comes to us. Xy squared plus 2 over 2xy squared minus, now here, in this case, to get a common denominator of 2xy squared, we have to multiply the bottom. Well, it already has a 2, so we don't need to worry about the number, but it doesn't have an x, so we have to multiply it by x. And that only has y, but we need it to be y squared, so we will make it multiply it by x and another y. But if we multiply the bottom by that, then we have to multiply the top by that as well. And so what we get is xy times y plus 2 over 2xy squared. That's subtraction, by the way. I hope that makes sense. We did the same thing we did here. Here we made a common denominator by multiplying by 5 over here and by 7 over here, and we multiply the bottom and the top by the same number. We did the same thing here, but here we want the common denominator to be 2xy squared, so I had to multiply the bottom by xy and the top by xy. Now with this, we are going to have to, Amy Tuck, distribute it, right? We're going to have to rainbow it. We're going to have to put it in. So xy will get multiplied by y, and xy will get multiplied by 2. And in the next term, as I write it out, I can say it equals xy squared plus 2 over 2xy squared minus, and then we can distribute this. So xy times y will be xy squared, and xy times 2 will be plus 2xy. And again, the denominator stays the same, which is 2xy squared. And so now, just like we did here, we can combine them into one term and actually collect our like terms. So we have xy squared plus 2 minus, and remember, this minus sign is going to apply to all of this stuff, so we're going to subtract xy squared. And we're going to subtract 2xy, because remember that negative sign will distribute in. It applies to the whole fraction. We're subtracting all of this. So we subtract xy squared, but we also subtract 2xy. And with that in mind, we say minus 2xy, just like that. And lastly, once we've done that, we can collect our terms. So we have xy squared minus xy squared. That will just cancel out to nothing. So maybe I'll use a red pen to show that. Xy squared cancels with negative xy squared. And what we're left with is 2 minus 2xy. Over 2xy squared. And the last thing I'd say is if we want to, we can take a common factor from the top, and that would be 2. 2, that's right. So I could factor out 2, and we would get 1, because 2 divided by 2 is 1, minus, and then 2xy divided by 2 is just xy. My minus signs keep disappearing today, and I'm not sure why. Not sure what I'm doing. Anyway, divide by 2xy squared. And now, because we only have multiplication here and multiplication down here, we can actually cancel out, not factor out, but cancel out those 2's. And that's going to leave us with our final answer of 1 minus xy over xy squared. And there's nothing more I can do to factor that, so that is the final answer. All right, so a lot of work there, a lot of steps, I know. And this stuff takes practice. Multiplying and dividing rational expressions is really easy and simple. Adding and subtracting them, a lot more complicated. All right, it's a lot more challenging, to be sure. And it takes a little bit of practice. All right, practice being the operative word. Now, remember we have to state restrictions. And we always state our restrictions from the beginning. So if we look here, from this side, if I set x equal to 0, then the whole thing would equal 0. And if I set y equal to 0, the whole thing would equal 0. So x can't equal 0 and y can't equal 0. And then over here, again, if I set y equal to 0, the whole thing would equal 0. So y can't equal 0. So those are my restrictions. X cannot equal 0, and y cannot equal 0. All right, so there's the simplified form, and those are the restrictions. All right, I want you to try this one here first on your own. Pause this video, and after a few minutes, you guys can come here and watch me do it. All right, I'm going to assume that the teacher's paused this, and now we're going again. So let's look here. If we look, we have a factor on the bottom here and a factor on the bottom here. And I'm going to make a simple note. First, let's check our restrictions. The restriction we get from this, x plus 3, is that x cannot equal what? Well, we just flip the sign to make it equal to 0. This term can't equal 0, so we say x cannot equal negative 3. Because if it did, this bottom term would become 0, and we can't divide by 0. Likewise, this one tells us that x cannot equal negative 2. Because if x were equal to negative 2, negative 2 plus 2 would be 0, and that term would be impossible. So first things first, those are our restrictions. Now, let's look at our greatest common, or our common denominator, and we're going to make a note. You can always multiply one denominator by the other. To get a common denominator. Right? In this case, we can always get a common denominator by multiplying x plus 3 times x plus 2. And that's in fact exactly what we're going to do. So our common denominator is going to be just these two things multiplied together. X plus 3 times x plus 2. Now, with that in mind, let's rewrite this line. Well, we want the common denominator to be x plus 3 times x plus 2 rather. To make that the denominator, we had to multiply this term, top and bottom, by, well, it's already got an x plus 3, so we need to add in an x plus 2. So x plus 2 times the top, and x plus 2 times the bottom, just like that. When we do that, we end up with what we already had on the top, which is x minus 5, times x plus 2, times the number we multiplied in, right there. And there we go.